Let's go to LeetCode 2597. The number of beautiful subsets. For this question, it gives us integer nums and integer k, integer array nums and integer k. And let's find the number of subsets which is beautiful. And the subset should not be empty. And also, you say that beautiful subset is that does not contain two integers with absolute difference equal to k. And you say that two subsets are different if and only if the chosen index is to delete are different. So that means if we have for example 2, 2, 3, right? So if we delete these two, but that we have 2, 3, right? Or we delete these two, right? We have 2, 3. So they consider these two subsets as difference. So this simplify our problem is that we don't need to worry about the duplicates, right? We don't need to dedupe. So we know this is a subset, right? Subset, we have two ways to do the DFS, right? Well, why we think this is DFS? Because the nums length is small or equal to 20, right? So 2 to the power 20 should be should the time complexity to is this range, right? So that is 10 to the power 6 should be good enough, right? So this is a subset. We have a problem which is subset, right? And there is some condition is that that cannot contain two integers with absolute difference equals to k, right? So for subset, we know DFS, we have two ways, right? Is that for every number, we have select, right? This is select, or non-select. And so this is, so under the select number 1, right? It's number 2 has select or non-select. And when we need to have index, index goes to the last goes to n, right? We add all the leaves to our result. And another way is that we have, for example, this is empty tree, right? Empty tree. We can select nums 1 or nums index 0, right? Can select. So under when this select, right, we can continue to select nums index 1, right? And under this index 1, we can select here index 2, right? So when this is not select, we just backtrack, right? We can select index 3, right? And then backtrack and backtrack, right? So under when this 0 select, and when 1 is not select, we can select 2, right? And also on the when 2 select, we can select 3 or not select 3, right? So backtrack. So under this condition is that for every list, we should add it to our result, right? So we can just write our solutions. The things that we remember for the backtrack, right? We need to have a list of integer as pass. And for this question, if when we add a number into it, and we check if this kind of numbers minus k or plus k, right, exists in this list or not. If it doesn't exist, then we are able to add it. If exist, right, then we cannot add it. So this can be one of our trim condition, right? But if we check every element in the list, right, then actually we are not asking those kind of list. It's just ask about the one thing is just ask about how many methods. Another is that if we check this kind of list one by one, right? This will be an O(n) time complexity to the check. So we should do it better, right? So what about we use a set, right? Set trying to see whether when we add, trying to see this kind of nums minus k exists or not, right? And but the thing is that if we on the set, when we remove, if we are able to add to the set, and if we remove this kind of element in the set, then it may have some problem, right? Because if it already exists previously, then we remove the previous added this kind of number, right? So we can use a map and to store the path. The key will be the numbers we are going to add, and then the value will be the counts. Only when we remove from the map the counts equals to 0, then we remove the keys from the map. So let's begin to write code. In that case, it will be 2 to the power n time complexity. So let's write code for this, right? We have options to sort these nums or not, right? The thing is that for this kind of array sort, it's normally used when in DFS dedupe, right? So that is when so that we know if nums I equals nums I minus 1, right? And also this I is greater than index, we should ignore this. So this is normally used for dedupe. For this question, it doesn't need a dedupe, right? But we can also still sort. The reason is that we just when we add this kind of nums, right? We just need to check whether nums I minus k exist in our map or not. Otherwise, we need to check minus k and plus k, right? So in that case, is that for our 2 to the power n, it will multiply by those kind of operations or do 2 checks, right? So this so we can actually do the sort here. Both will work, right? So let's so what we do is that we need to have result equals new int 1, right? What we do is that we should have DFS nums, and we from index 0, right? And so what we need is map, right? We don't need the actual path. And the key new hash map key will be our those kind of number, right? And the value will be our counts. And we have a result. In the end, we just return result 0. So index hash map. And also we should have a result, right? And the thing is that for every nums, right? For every index, we want to check. We should add to our counts, right? And before we add to our check counts, we need to make sure our map is not empty, right? So that is our path. Let's have int n equals nums dot length. So if map is not empty, then our result 0 should increase by 1. Then what we do is that for int I equals to index I smaller than n, I plus plus, right? So what we do is that if it's a map, because we sort, right? Sort here, so we just map contains key nums I minus key, right? Otherwise, we are contains key minus key and plus key. We should continue. Here we you see that as long as those kind of indexes are different, then we consider different subset. So we don't need to dedupe, right? So if we need to dedupe, is that we'll say if for this kind of nums, I equals we should have if I greater than index and nums I equals nums I minus 1, we should continue, right? But for this question, we don't need to dedupe. So what we do is map merge, right? We add this kind of nums I 1 integer sum, right? And DFS. And after we DFS, we should also get this out, get this counts smaller, right? Should get the counts use minus 1, right? And also doing after this, if map get nums I equals 0, let's remove this key, right? So this is backtracking. And under this backtracking, we should do DFS I plus 1 map result. Okay. So this will be new hash map. We should have K here, right? And we can also convert this one as Python code, right? Python code should be very similar. So we should have nums sort. And then we are going to have result equals this. And we should have DFS, right? DFS nums K0. We should using default. So we should have something called a default declare. So which called test, okay. Default DICT. Should have int, right? And pass, and we should have result. Let's put this result as 0 first, right? Then return result 0. Okay. So we should define this kind of DFS like DEF or DFS. We need to have nums as a list or int, and also we should have pay as int, and we should have index as int, and we should have map, right? So we call count as map, and we should have result. Should have result. Let's has as a list. Okay. And so what we do is that n equals length nums, right? And if map is not empty, so we should have map count, right? Count. We should have result 0 plus equal to 1. And then for I in range index to n, so we'll say if nums I minus k in this count, right? Count. We should continue. Then we should have map count nums I plus equal to 1, right? And also should have count nums I minus equal to 1. So what we do is that if count nums equals to 0, right? Then we should delete count nums. Then here we should DFS, right? DFS nums should have k and I plus 1 and count list, right? Result